Hello, friends. This is Akulmach, and my name is Chandrakant. And you know that supernovas are the world largest explosions that we can even imagine. Supernovas actually explode with so much energy that it releases the energy that sun produces in 10 billion years all together in one shot. So these are very energetic explosions, and many times these explosions basically outshines the entire galaxy. And we have got enough information that every 50 to 60 years there is one supernova, either in our galaxy or any in any other galaxy. So, since these explosions are really energetic, and supernova usually involve large star, larger star than sun. So, the big question that scientists have to answer is that you know when we observe supernova, how much distance we must have, or if there is a supernova nearby which explodes near earth, then will earth survive? So how much distance is adequate in order to survive a supernova? That is a question that we are answering in our live stream. And by the way, friends, if you have any questions, suggestions, you can actually send in your comments, and they will display here behind on the TV screen over here behind me, and I can read, and I can respond to your questions. All right, so we already know a lot about supernova. These are very energetic explosions, and these are huge explosions that you can think of. And they emit lot of radiation, and if you are in the vicinity you will immediately get fried. So if there are unfortunate planets in the close vicinity, they will not they will examine the supernova. They will also experience the immense heat which is getting emanated by the supernova, and the plenty of radiation, all kinds of radiations emission happens out of supernova. So if we are examining the supernova from far off distance, okay, we can, like the beauty of this grand explosion. But if we venture too close, then there is no force which can protect us. We'll instantly fry because of the radiation. Now, even though we have known that Earth has experienced few supernovas, but obviously after 5 billion years of existence we know that earth still exists. That means we have passed through supernova, even either through a supernova which after the explosion has occurred already, or we have maintained certain distance. So even though life may be affected on the surface, but it did not impact the solar system or planet in a very big way. So the big question is how far we should be in order to survive a supernova. And there has been many answers, but none of these answers are concrete enough with certainty. Okay, if there is a supernova at this distance, we will survive. If there is a supernova at X distance, we may not survive. No, that kind of answer has not come. So in order to answer this difficult question, we have to examine what we have found so far on Earth. We know that we have survived supernova. That means we have never experienced a supernova close by. That means nothing has happened physically to our solar system. So in a pursuit to find how supernova affect not only the initial explosion, but we have also found that on Earth in the deep ocean, a particular isotope of iron, which is iron 60, that occurs only when a supernova happens. This is a very peculiar isotope of iron, and it has a half life of 2.6 million years. Very specific element which is produced at the time of supernova. So this iron 60 has been found in the bottom layer of the ocean, and not only in the bottom layer of the ocean, iron 60 has been found in the ice core, and it has been found in other places all across the earth, deposited on the surface 2 million years back. So it means that even though there was a supernova of which there are no records, because when the supernova explosion happens, there is a lot of radiation, and when the radiation hits the earth, it leaves a sign. It actually interacts with the material on earth, and especially the gamma ray which forms the major part of the explosion of supernova. It actually affects the material on Earth because of this radiation. So we know that 2 million years back, even though we find this iron 60 being deposited on Earth, there is no evidence of any close by supernova. So this is a baffling find, and we also now tested this iron 60 evidence of iron 60 uh, when we went to the moon and we examined the rocks on the moon. We found iron 60 there also, deposited 2 million years back, and also on Mars. So we now have a clear date, three candidates of iron 60 being deposited without any evidence of supernova having happened. So this actually shows that many years after the supernova, this material got thrown towards the solar system, and hence more than one body, that means Earth, Moon, and Mars, that we know of, were affected by this highly radioactive iron. So this proves that the supernova may also affect you indirectly. And when the direct, when we say that how far is far enough, so we are only looking at the direct implications of supernova going a bang, where we actually start seeing the explosion right there in the night sky. And when we see this explosion, we are definitely seeing the highly energetic gamma ray particles and X-ray particles, which are now traveling at the speed of light and reaching Earth. And they may actually fry us if we are very close by. However, even if we are not close by, the material like iron 60 and others, which are slower in their motion, are getting thrown out of the supernova and may take hundreds and thousands of years to reach nearby planet. And this is exactly what has happened. This highly radioactive isotope of iron has actually landed on Earth and other planets in solar system at least 100,000 years after the initial bang. So it depends, if this radioactive material is too dangerous, the supernova can still affect you much after the initial bang. Even though the supernova remnants are not visible, the material will reach us eventually and then cause us harm because of radioactiveness in that material, just like iron 60 has. So if we are quite far enough, then our atmosphere is thick, which can protect us from the cosmic rays and the harmful radiation from supernova. In the process of protecting us, the atmosphere may suffer a bit. For example, there is a ozone in the higher atmosphere which may get removed from the atmosphere. So there has to be some sacrifice, but overall the planet will survive because of this initial radiation. But if the material is getting deposited after a few thousand years after, or 100,000 years after the supernova, there is no way our atmosphere will be able to stop this material. So I think we have to basically keep in account of this phenomena as well. It's not only the initial radiation which will affect us negatively, but the remnant of the supernova, which are slow in their speed, may reach us later on after the explosion has happened, come and gone, and the explosion is even not visible in the sky. Some of this material can fall on Earth and can harm us. So based on these inputs, scientists now believe that they have been able to come out with a safe figure of how far we should exist from a supernova, and that distance is 160 light years. So anything which is beyond 160 light years away, we are fairly safe. But anything which is within this radius of 160 light years from Earth, there could be a chance that even though we are not affected immediately by the initial bang, but later on we may get affected by the radioactive material which is also thrown out from the supernova and will eventually reach us. So I think now the figure is 160 light years, radius of 160 light years. Any nova going bang within this radius is can be dangerous for Earth. Anything beyond 160 light years is safe. So I think this is now sort of confirmed based on all kinds of studies that scientists have been able to carry out. And I think based on this study, we are now increasing the boundary of safe distance from a supernova, which used to be about 90 light years, but now it is at 160 light years. So, friends, this is a great find. It is related to our survival, our well being, our health, not only humans, but entire Earth. What do you think about this? Do you think this is the end of this study, or there is more to this? I will like to know your comments. So, friends, thanks for watching me. I will catch you again very soon in the next edition of Akulmach Live. Until then, have a nice time. Bye bye for today.